Hey guys, Chris from Harmony Turbines here. Sorry for the being out of uniform, so to speak, but it was chilly today, and so had to put on sweatshirts, and this was the only one I had. It's nice and dirty, but that's okay. Anyway, we have been working really hard the past couple weeks on generator testing. In fact, the past couple months, it's all been generator testing. We have got, oh man, I don't know, we're probably up to 11 or 12 different generators that we've been testing. And some of the newest ones we got in are lending to some very interesting results. So in all of that testing, looking for the right generator to pair with Harmony, one off the shelf that we can just very quickly sort of move into low volume production when the time is right and as we lock in on the components we need. One of the things that we're running into is we need the ability to test the load that we're putting on the generator. So we have a physical load that you're putting on that is the gear ratio that you would have. So your wind is generating torque and spinning the turbine, and then the gear ratio in between the turbine and the generator allows the generator to spin faster. But one of the other very important pieces of that is the electrical load that you're putting on the unit, how much resistance you're putting on it. And that, the lower that you go in your resistance, the higher you actually get in your output. So this, we call it our bench test. It's not really a bench, it's a drill press. Some of the early videos that we might have shown clips of bench testing in the back, it was almost embarrassing how crazy we were doing it. Wires everywhere and a handheld drill. This is so much easier. We can now put whatever ratio we want in here. By changing the belts on the inside, we can go from 100 RPM all the way up to 1,000 RPM just by changing the belts inside. We're driven in the back by a nice 1 horsepower AC motor, so we have plenty of torque, and then the unit's nice and rigid, so we don't have to be hanging onto things, putting things in vices. We just lock it in to the drill press, and then we can do the testing. Now you'll have to excuse this little purple thing in the middle. We've been playing around and doing testing. We actually burned up the top end of it, so you'll see a little bit of mushed out material here as we kind of remade a socket, and we're 3D printing a new one, and then ultimately we're going to machine one out of aluminum so that we don't have to worry about destroying the little coupler that we have. But we just needed a quick way to couple the generator to the drill press, and this allows us to do that. So hopefully it won't fail for us when I'm doing the demonstration here, but there will be a little bit of wobble. That's because we had to remake the upper end on this. So right now we have this set to somewhere in the 400 RPM range, and we had been testing at lower RPMs. But what I wanted to show you was this little unit, and there is a twin brother to it in our truck that allows us to basically vary the resistance or vary the electrical load on the fly just with the change of a knob. So I'm going to switch positions over here and turn this on. Again, please excuse the wobbling. So there's a little bit of wobbling there, but what we're doing is running at a constant 400 RPM. And we have the resistance right now set to 20 ohms, so 133 watts. As we increase, our ohms go down and our wattage goes up. So now we're coming into around 200 watts as we get down to 11 ohms. So if we back it off, 12 ohms we're dropping, 13 ohms dropping more, 14, 15. So it's an inverse relationship. As we lower the ohms, puts more load, electrical load on the system, and then we get more watts out of that system. So this, with the turn of a knob, lets us do many, many things that before required all kinds of different wires and different resistor values. You saw in some pictures we had, green resistors, and then we bought variable resistors. This little guy is beautiful because we can run it right in our truck, change the resistance on the fly with the turn of a knob, and it's beautiful. So bench testing allows us to already know where we're going to be with our output so that when we get on the road, we're not wasting a lot of time trying to figure things out from scratch. That's about it. We will get into some more of the generator information probably in our next video. We'll show some very interesting things that we're doing there. But yeah, probably 12, 13 different generators that we've been trying over the past couple months. We're about to you know, in the next couple days, be able to take these out on the road and see how they do with the turbine. So that's about it for the electrical load resistance testing, and this video just explaining a little bit of that for you. Thank you to all of our supporters, our Patreon users and supporters there, our YouTube followers. Thank you to our investors who have been with us this entire journey. Again, we've been doing the testing on our units that have been kind of Mark II from summer of 22 until now. So we've been at this, at the time of this video, it's a little more than 2 years that we've been developing in the most mature iterations with our Mark II turbines and beyond. But now we're getting into a lot more exciting stuff with our generator testing, our single scoop pair testing, and so on and so forth. The entire goal is to get into our alpha testing on the side of the building. After that, into beta testing, where we have our early adopter customers, and then of course into low volume production. We're going to continue sharing that with you. So thank you. Chris from Harmony Turbines, signing off. Harmony Turbines. We now have the power to change the world.